Okay. So far we have discussed about different uh, things with respect to the C language. From today, we will move into our uh, subject, that is data structure and algorithm. First, what is data? So you can say anything which is in raw form is called data. Now suppose, for example, suppose this one, 0, 1, 2, 3. Now this is purely in a raw form. Why? Because if I tell you 0, 1, 2, 3, you cannot predict what is the meaning of this 0, 1, 2, 3. But if I say that this is my PIN number, then you can conclude or give some proper or exact meaning of this raw thing. So if I say only 0, 1, 2, 3, it is purely a raw data. Okay. But when I saying that it is my PIN number, then you can conclude, you can understand what is the meaning of this raw data. Then it becomes information. So from this data, you can conclude, you can understand. So it becomes information. So it is giving you some information that this is the PIN number. But only 0, 1, 2, 3 will not give you anything. That's why it is called raw form. And the raw form is called data. So anything which is in raw form is called data. Now, why we are discussing about data here? Because whenever we are writing any C program, we are declaring some variables. We are declaring integer variables. We are declaring float variables. So it means these variables are actually storing some data. Okay, these variables. So suppose I am writing x equal to 5. It means this variable x store this value 5. This value 5 is a data. Okay. Now, whenever we are writing any program, so if this is a program, now you already know what is the definition of program. Program means set of instructions. So if you are writing a set of instructions, okay, then you are using which memory? You are using the RAM memory. Okay, when we are writing a program, we are running it, compiling it or executing it. What we are doing? We are using the RAM memory. In the RAM memory, the code will be executed and the output will be shown. Okay. So whatever we are doing, that is done in the RAM memory. But when we are saving the program, when we are save as, suppose we are saving this program as a.c. Now, this one having a place in the hard disk. But whatever data we are giving to run the program through scanf, all those things are in RAM. Okay, we can store this data in hard disk if we use file management system. In C language, there is a file system which will help you to store the data which we are using in our program in hard disk using file management system. But whatever data we are using in our program taking through scanning, seeing the output, all means all data are stored in RAM. That's why when we are next time we are again running, we are getting sometimes garbage values because the same RAM memory is utilized again and again. Okay, so that's why these variables are not stored, they are overwrite. Every time these variables are overwrite by the next program execution. Okay, so whatever data we are dealing here, we are dealing in the RAM memory. Remember this thing. This is very important. Now, so we have understand that what is data, what is information, and actually which data we are talking about. We are talking about RAM memory data, not the hard disk data. Okay, so now the next thing coming is structure. What is structure? You already know that in C language there is structure. Now this structure is different. This is not C language structure. This is called organization. This is called organization. Means we are storing the data in some organization, some model we are using to store the data. Okay, so this structure means we are storing the data in some form of organized way. Now, what is the purpose of this data structure? Why we are using data structure? We are using data structure so that we can easily access the data, easily access the data. Now, how we can access the data? We can access the data in different operations. What are the different operations? The different operations are, we can insert data, we can delete data, we can search data. So these are the different operations we can perform. On this RAM data, that's why we are storing the data in such a format so that we can easily access them. Now I'm giving one example. Now see, the example is very well-known example. Now factorial. Now you remember that factorial having two different definitions. I hope you know this. One is called iterative, another is called recursive. Okay. Now I will discuss about this recursive one. Now, if I say, if I discussing about recursive definition of factorial, then you have to know what is recursion. Recursion means function calling itself. That is called simple definition of recursion. When a function calling itself, it is called recursion. There is one iterative definition which we use for loop or any loop. Okay. Now I will discuss about this part, recursive. So what is the definition of recursive factorial? N factorial equals to n into n minus 1 factorial. This is the recursive definition. What is the iterative definition? N factorial equals to n into n minus 1 into dot 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 into 1. So this is iterative. And this one is recursive. Why? Because if I want to measure the factorial value of 1, I must have to know the factorial value of n minus 1. So within the factorial definition, so factorial of n is calling factorial of n minus 1. That's why it is called recursive definition, function calling itself. Okay, so I'm not going to the exact definition. I'm just giving you the hints. We will discuss about it later. So there is one terminating condition. Now this terminating condition is very important in case of any recursive function. Whenever you write any recursive function, you must have to know what should be the terminating condition. Otherwise, recursive function becomes infinite. Okay. Now, what is the terminating condition for this factorial one? Sorry, factorial, that factorial of 1 is 1, or you can say factorial of 0 is 1. So this is the terminating condition. Is whenever n is equals to 1, you have to stop. Otherwise, it will call again and again the n minus 1. So it may go into negative part. That's why we have to terminate. Okay. So in this way, if I want to measure the value of 5 factorial, what will happen according to this definition? I'm not going to the code. I'm just defining it. So it will call in this way according to the definition. Now factorial n, it is not 1. So it will call, sorry, 4 into 3 factorial. In this way, it will call 3 into 2 factorial. And again, according to the definition, it will call 2 into 1 factorial. So you can understand that it will call again and again the function. But now, since the definition having the terminating condition, whenever n is 1, so here n is 1, you have to stop. Now see, so this is your last calling function. This is your last calling function. Now see how this multiplication will be executed. First, this one will be executed first, then this one, then this one, then this one. Very clear? How they are called? First this one, then this one, then this one, then this one. Now see, the calling sequence is 1, 2, 3, 4, but the multiplication sequence starting from here, 1, 2, 3, 4. So it is always in a reverse order like this, reverse order. So we need a particular type of data organization. We need a data organization or structure which will support this type of format. And some of you already know that this is called the stack data structure. Now you can understand why we need data structure. If there is no stack data structure, which is called last in, first out, or first in, last out, we cannot do this problem so easily. We cannot do this problem so easily. Each and every recursive function always use stack data structure. So you can understand we need special type of data structure. Otherwise, it becomes very difficult to execute because the calling is in a different order and the execution is in a different order. So better write it calling in this order and multiplication in this order. So that's why it needs a different type of data structure. And the data structure here used is stack data structure. So we can understand, so from this example, we can understand that we need special type of data structure to access our data easily. Now, what do you mean by access? Access means we can insert, delete, search, sort, whatever operation. So we need data structure. Now I am going to define the exact definition of data structure. So how to define data structure? So the definition of data structure must be like this. The logical or mathematical model of a particular organization of data, the logical or mathematical model of a particular organization of data to access the data easily is called data structure. Sorry, one thing I missed, structure. You must mention one thing, the logical or mathematical model of a particular organization of data to access the data easily in RAM. This is very important. In RAM is called data structure. Now see, we access data in hard disk also. That is called file management system, which is done by operating system. We can use to access hard disk data using third-party software that is called DBMS, database management system. It is a application software you have to install. It is not inbuilt, but this file management system which is used by operating system is inbuilt. So you have to add this. So this two data structure is for hard disk, and they are called generally file management system or database management system. But data structure is always used purely for RAM data. Now suppose this DBMS data will be finally stored when we are accessing some file. Suppose we are accessing some file. In which memory we are copying the file? We are copying the file in our RAM memory. Then we are modifying it and then we are storing it. So whenever the data will come into RAM for a particular hard disk data, a particular file, when we are accessing, it will come into RAM. And again, it will be converted to some data structure. Logic clear? I hope the logic is clear. So the logic is, whenever you are accessing your data in RAM, that is purely data structure. Whenever you are accessing your data in hard disk, okay, then it is file management system. But whenever you are copying or checking or opening any file in a hard disk data, it must be stored in a RAM with some data structure. Okay, very clear? So this is the basic definition of data structure, the logical or mathematical model of a particular organization of data. What is the purpose? To access the data easily in RAM. And this is called data structure. So we have already defined the first part of our course, that is data structure. Now the second part is very interesting, which is called algorithm. Okay. Now what do you mean by algorithm? So again, if I want to define algorithm, what do you mean by algorithm? So again, algorithm is nothing but it is a set of instruction, right? We are logically writing some set of instruction. Okay. So so you can say, then what is the difference between program and algorithm? Now generally algorithm must be in our you can say in our own language, without any syntax. There is no syntax for algorithm. No syntax is required. But whenever we are writing a program, we have to write a special type of language, either high level, low level, okay? And there must be some syntax. I cannot write it randomly. We have to follow some syntax. So that, but both are representing what? Set of, you can say, defined, you can say set of defined formula. Set of defined formula or steps to solve a problem. So this is, you can say, a particular definition of algorithm. Set of defined formula or steps to solve a particular problem. Okay, but what is program? When we are writing some special language with some syntax to solve a problem, then it is called program. There is another thing which is intermediate between algorithm and program, which is called pseudocode. Pseudocode. So you can understand this is intermediate between algorithm and program. Not almost same as syntactically correct as program, and also not purely our means own language. It is some intermediate thing, and you can say combination of algorithm and program. Okay, that is called pseudocode. I will give you some example. So we understand that what is algorithm. So to solve a particular problem, we will give you some set of instruction or defined formula. Those set of instruction written in your own language is called algorithm. Now, whenever you are writing some algorithm, you must have to remember a few things. The first thing, it should have some, it should have, it should have some input. Okay, so whenever you are writing some algorithm, you have to give it some input. Okay, then the next thing, it should have one or more output. Means suppose you have given one improper input, just like same as the previous day's problem, I have given one wrong input, then at least it should print improper input, or the your input is wrong. So it should have one or more. According to your problem, it may have many outputs, but it should have at least one output. Okay, these two things are very important in case of algorithm. Then the next very important thing is it should be finite. It should be finite. Suppose you are writing a for loop with infinite condition, then this is not a proper algorithm. It should stop after a finite number of steps, and it should give you some output. Okay, then the next thing is, that is also important, that there should not be any ambiguity in words. Ambiguity. Ambiguity means double meaning words. Suppose I am using in my algorithm, I am using bank. Okay, now bank has a double meaning. It may be some bank where money transaction is occurred, or it may be some river bank. Okay, so in your algorithm, it should have some definiteness, no ambiguity. Whatever you are saying, it must be definite, only one single meaning. So these things must be checked whenever you are writing any algorithm. So algorithm is always for some problem. So there must be some problem, and algorithm is the solution of the problem. Logic clear? It will give you step-by-step solution. Now, whenever there is algorithm, it should follow this four very important things. Number one, some input, one or more output. Then it should be finite, and there must be some definite definition of or meaning, and no ambiguity. These are very important. These are very important whenever you are writing any algorithm. Okay, now program, where we have to follow some syntax. Okay, but in case of algorithm, there is no syntax, only these four rules. You can say these are the rules you have to follow, but you can write it in your own language. But what is pseudocode? Pseudocode is something which is intermediate between algorithm and program. Okay. So now I'm taking one simple example that for a particular problem. So I'm writing a particular problem, prime number. Now you already know what is prime number. So the problem is like this. Check a given number is prime or not. Now see, okay, so this is one kind of your programming concept based problem, but I can also give you a practical problem also. Let's first check this one. So whether a given number is prime or not. You see, you can solve it in many ways. I don't know whether you know different techniques of this or not. Okay, before that, let us start with some practical examples. Say a practical example. A practical example is that you have to go from, suppose this is one city and this is Kolkata, and you have to go Delhi. Okay. So you have to, from Kolkata, you have to go Delhi. You see, so this is, you can see one problem. How you can go from Kolkata to Delhi? How? So this is a problem. And what are the solution? So number one solution. Number one solution. You can go Kolkata to Delhi by car. So this is one solution. Okay. Another was giving, I will go by train. Okay. Another one is giving solution that I will go by plane. Sorry. Go by flight. Okay. So these are different solutions. This is solution number one, solution number two, solution number three. So remember, every problem should have many solutions. It means many solutions means many algorithms. Many algorithms. Algorithm 1, algorithm 2, algorithm 3. See, those who have done sorting, they know that there are different types of sorting techniques. So one problem, many solutions, many algorithms for a particular problem. But the question is how to analyze which one is better, how to analyze which one is better. Okay, that is very important. In case of any algorithm, you have to analyze it whether your algorithm is good or not. See, for this particular problem, there are three possible solutions. Okay. Now, how these solutions are different? They are different with respect to, see, time and cost. They are varying with time and cost. If you go by car, it will take the maximum time and your cost may be very high. If you go, see, there is another solution you can think. You can go by cycle. Now, with respect to time and cost, this will take the maximum time, but cost is very low. So time is very high, cost is very low. Car, time is high, cost also high. Train, yes, time will reduce little bit, cost also reduce little bit. Flight, time is very reduced, but cost is high. Okay. So every problem solution must be measured in a balanced way, whether it is suitable for me or not. That's why there are different solutions and they have different, its own advantages in different sectors. I have given one example yesterday, selection short. Selection short, remember, selection short is the most practical shorting which you can apply anywhere because it will take minimum number of swapping. So practically this is the best shorting technique, but there are many shorting techniques which have its own advantage and disadvantage. Similarly, for a price, so these are the different solutions, these are the constraints for a particular solution. Which one you want? You want to reduce the time, then you will go by flight. So you will choose this one. This solution is better if you want to minimize the time. But if you want to minimize the cost, then this one will be best. If you want to make a trade-off between these two and want to minimize both, then you will go for this. So it depends on your requirements. So this is called analysis of an algorithm. So in which respect you can analyze your algorithm? You can analyze your algorithm with respect to, remember this, time and space. How much time it required to execute or give the output, and how much memory it will utilize. With respect to these two terms, we can measure or analyze which one is better. Okay, but see, day by day, this time, the space is increasing. When we started our programming, it is 1999. I bought my first computer and I have only 64 MB RAM, you can understand. Now, minimum 4 GB RAM for every device. So it means now the space is always increasing. But when in 1999, I get 24 hours in a day, similarly, till now, I will get 24 hours a day. It is not changed. Yes, computer speed has been changed, speed change, but total time, that is not changed. So that's why, because I'm giving you an example, so that's why we give more stress on this time. That's why you will heard that there is a term called time complexity. Yes, there is another term of space complexity also, but we give more stress on this time complexity. So with respect to time complexity, which algorithm is best? That will be the best solution. Okay, so why I am considering this prime number solution? Because this solution, this prime number solution have means problem having many different solutions. Okay, what is prime number? You already know a number. So what is prime number? Prime number is a number which is divisible by 1 and itself only is called prime number. Correct? You already know the definition. Now how to, so if a given number is n, then how to check whether it is prime or not? So number one solution is, I will start from 1 and up to n, start from 1 up to n and divide this given number with these values. If only 2 times it is divisible, then I will say it is prime. Am I clear? Why? Because suppose 7. So I will divide it by 1. It will give you, yes, divisible. Then 2, no. 3, no. 4, no. 5, no. 6, no. 7, yes. So how many times it is divisible? Among these 7 times, only 2 times. It means it is a prime number. If it is divisible more than 2 times, it is not a prime number. So this is simple solution. Okay.